So get out your packet that says transformations with technology. Okay.
Technology.
With technology. So we've been talking about function notation as a packet. Pick that away in. Okay. So we've been talking about function notation and all of the packets you've been doing that started point of view one and the multiplied addition one. It all had to do with changes on your original function. So you had an f of x, and then we did something to it. We added to, we subtracted to, we did something. Okay. So now we're going to be doing the same exact work, except we're going to do it in the calculator. Okay. So if you take a look at your package, skip that first paragraph. I'm going to explain it in better, an easier way to understand it. So just skip that first part and go down to number 1. And it says compare y is equal to f of x and y is equal to f of x plus 2. So that's the first one we're going to be doing. So we have our calculator. Everyone grab your calculator. And before you do anything, I want you to put second plus 712. Clear it out. Second plus 712. And it should clear everything. Okay. So you clear that, and you hit your y equals button. And it should be all nice and clear. Y equals. Now, you should see two things. Look at A, and it says y1 is equal to x plus 1. That's what you're going to have in y1. X plus 1. X. Wait, I didn't get to that. Y1 plus 1. So you have x plus 1. Okay. And in the second one, if you look up above where it says like B, there's a little box that says y2 is equal to y1x plus 2. Okay, there's a specific way to get down, to get to a y2, okay, or to make that y1 appear in y2. So right here, you're going to be writing y2x plus 2. But to get that y1 in there, you're going to hit bars.
What are you talking about?
Wait for it. So scroll down to that second y2. You're going to hit bars. You're going to go over 1 to y bars, y variables.
Wait, what?
There's my button. Variables, you hit the arrow over to y variables. Then you go to 1, so function, hit enter. And then it gives you out the y variables. You pick the first one. And it'll appear right here in your y2.
Ooh, that's
Once you get a hang of it, it's not too bad. Okay? So did everyone do that? And my steps are right over here on this other side. Key press history. So you just hit the variables, you go over to the right one, you hit enter, and it should get you that. Okay? So you have y1, and then type in the rest of what it says. So it's going to be y2 is equal to y1, and then parentheses x, and then plus 2. Now, that second equation, that y2, that's going to be the equation you use for those 3 graphs. Right? Okay. And I'm going to be passing around a math pencil. Your original graph, that x plus 1, when you can actually graph it and you can see what it looks like. It's going to be that first one that pops up. That one you're going to draw in your regular pencil. The second one, see that one, this graph right here, where it says graph? That's my y plus 1. It crosses at y is equal to 1. Draw that in your pencil. In your math pencil, you're going to draw the next one. So you put this in your calculator, you hit graph, and it'll graph you a second one. That second one, that new one, is your transformation. And you're going to draw that one using your math pencil.
what is the difference between
The intersection 3, right?
Yeah, it should intersect at 3. What was your question?
Oh yeah.
Okay. So it should intersect at 3.
What about going up? The y axis. What if it intersects?
At
3 and the other one? 3.
Negative something.
Does it matter how?
Not really. Not right now. Okay, and what you're going to do, that's for A. Now look at B. to x squared. So you're going to go back to your y equals once you've drawn that graph. And all you're going to do is you're going to change your y1. I'm going to delete that out. And I'm going to put x squared in there. Now, you do not have to change your y2 because it already recognized that y1 has changed to x squared. So then you hit graph. You have your x squared, which is just your parent function parabola, and then it draws another one. That second one is the one you're going to be drawing with your map.
So we just draw both of them?
Yep, you draw both of them. The first one with pencil, the second one with your map color.
Which one's the first one?
Your first one is your original parabola that goes through the origin.
What? Smart enough. This?
Yes. And then you're going to do the same for C. You're going to go back and you're going to change your y1 to 1 over x, and you're going to graph. You're going to draw your original graph, which you should know your parent function. 1 over x is your rational parent function. And so you have the hyperbola looking thing. And then the new one will show up. You draw that. Okay. Now, if you look at number 2, it has another little boxed in area. And this one says y2 is equal to y1x minus 2. You're going to do the exact same thing with the y1 is equal to x plus 1. But this time, your second line over here, you're going to change it, this plus, to a minus. And you're going to see what happens. Oops. So this will be minus 2. Don't worry about all that. And that first one is going to be x plus 1, so plug that in. And graph. So there's my original, and that second one being drawn is my new one. And you're going to go through this entire packet and graph all of those.
I saw that one.
No. If you do not have a calculator at home, I would suggest quickly doing all of the graphs and then come back to the generalization, which is down at the bottom, that question. It's asking what happens to the graph of the function when you add a constant to the function rule. Okay.
And it's something you wish the graphic calculator had. Probably. Really? How much is it? Hey, what's the difference between your calculator? So you got 83 is
It's just a little bit different, but then you
Oh, I'm sorry.
doesn't that.
See, I have to still put it out.